Right, so we are going to continue on from the previous session. Previous session we discussed questions from 21, 20, 19 and 18. Now we are working backwards. Next questions are from year 2017. Right. Now let's see what this question is all about. The following procedure was used to determine the molar volume of the unknown gas X. First, the mass of a rigid container of volume V containing dry air was measured as M1. Then the dry air was removed and the container was filled with an unknown gas X, and the mass was measured as M2. Both the dry air and the unknown gas were at the same temperature and pressure. Density of dry air is D. Which of the following expressions give the molar mass of the unknown gas? Now, interesting. Okay. So first of all, they have told initially there was this rigid container, right? So it will have a constant volume, rigid container, and it consists of only dry air. It consists of only dry air, and the volume of the container is V. And they are both maintained at same temperature and pressure. So temperature is T, pressure is P. Yeah. Now dry air and the mass of vessel, both the total mass, they have to the mass of the rigid container of volume V containing dry air. Here, mass of a rigid container of volume V containing dry air was measured as M1. So if I take the mass of container as M0 or something like that, mass of container, M0 something like that, and mass of dry air, we'll put mass of dry air, MdA, mass of dry air. Okay, so according to the data given, M0 plus mass of dry air, that is equal to what? That is equal to M1, is it? M1. But they have given an additional information, that is the density of dry air. Density of dry air is D. So if you contain only dry air here, the volume of dry air which will be V. So for dry air, you can apply this equation. For dry air, you can apply that equation for density or mass, right? What is mass? Mass equal to volume into density. We are still analyzing the first system. So mass of dry air, we have taken it as MdA. Density of dry air is D. Sorry, volume is V, density is D. So in the answers you can see dV is there. So mass of dry air, it's actually dV. So that is settled. Mass of dry air is dV. So I can say mass of the vessel plus dV, it's equal to M1. Okay, right. And then what they are doing is they are not changing the container. It's the same container, so it will have the same volume. It's a rigid container, volume can't change, volume V, and according to the question they are maintaining same pressure and temperature. Now they are replacing that with another gas, that is gas X, and let's say the mass of gas X is Mx, and this time the total mass is M2. That means mass of the container plus mass of gas X is equal to M2. Okay, M2, right. But from this equation I can find out an equation for M0. M0 is something we introduced now, people. So M0 is going to be equal to M1 minus dV. Why am I doing this? I don't want M0. M0 is something I introduced as mass of container. So instead of M0 I can use M1 minus dV, because this is for this, the total mass is M1, that is the mass of the container plus mass of dry air. Instead of mass of dry air we can put dV. So this, therefore instead of M0 now I can substitute this value, that is M1 minus dV plus Mx is equal to M2. Therefore Mx, that is mass of gas X, will be equal to M2 minus M1 plus dV, right? If not, you can write it this way also. Now if you take this whole thing as one quantity, this whole thing, then I can take this whole thing to the other side now. Therefore you will be getting M2 minus that whole thing, M1 minus dV. You can write it that way also. If you consider this as like let's say if you consider this as Z plus mx is equal to m2, so mx is equal to m2 minus Z, this way. That is mx mass of gas x. What's the question? Which of the following expression gives molar mass of unknown gas? So we have to find out molar mass of unknown gas. That is going to be capital M of x, molar mass of x. Okay, so they have given you the answers. In the answer R, T, PV, everything is there. Obviously they have for gas x, they have applied PV equal to nRT. Pressure is P, volume is V. Number of moles, we don't know. Number of moles, you can put mass of gas x divided by molar mass of gas x into RT. In the question, we are supposed to find out mx, capital Mx rather, not simple mx, capital Mx. I'll make that the subject. If I make that the subject, I will be getting capital Mx is equal to simple mx RT over PV. If you look at the answers, you have RT and PV in almost except for the first answer or in other answers. But we just figured out an equation for mx little while ago. Mx is equal to this value, m2 minus m1 minus dv. So molar mass of x, what is it going to be? Molar mass of x is going to be, instead of mx, you can substitute this value, m2 minus m1 minus dv whole thing into RT over PV. Very simple, this question, not very hard. The answers look big and intimidating, but it's not manageable. Sorry, it's not out of control, out of your zone. It's definitely manageable. Fine. So what do you think is the best option, Weaver? Best answer is m2 minus, so second one, no? Perfectly, the second one. Right. How many of you got the second answer after attempting this question? And did we try this at the class? When I explained PV equal to nRT, did I explain this at the class? Can't remember quite. Can I remember, Shifa? Did we do this? Fine. By the way, did or not, it's okay now. No, okay, we haven't done, right. Never mind. So I hope you guys got an understanding about this. In future, if you get a question like this is how you have to analyze. Done? Okay, right, fine. Next question. Right, next question has a small issue. The issue is you don't know the reaction, people. You don't know the reaction. So I will first give the reaction. I'll have to give you the reaction, and then we'll have to do it. Because these questions are from final papers. In the final papers, by that time, when you do the exam, you will know these reactions. But they have given you the information, so you should be able to figure it out. They have given you the reactant and product and everything now. Right, so you should have been able to do this question. You can't say you don't know the equation, because they have given you the reactant and the product. Aluminium nitrate decomposes explosively at high temperature to form nitrogen gas. Aluminium nitrate. What is aluminium nitrate? First of all, we have studied these things under chemical calculation. Aluminium nitrate, that is Al NO3. This is aluminium nitrate. At high temperature to form nitrogen gas. What is nitrogen gas? Nitrogen gas, in maroon color I have underlined. Nitrogen gas is N2. Remember, not N. It should be N2 gas. Oxygen, of course you know, oxygen is not O, it is O2. Remember, O2. Oxygen should be O2. And water vapor. Water vapor is not new to you. What is water vapor, people? Water vapor is going to be H2O gas. These are the products. What will happen to sorry, it is not oh my god, big mistake. It's not aluminium. Yeah, that's what I was wondering. How can nitrogen be formed when aluminium reacts? It's a terrible mistake. Sorry, it should be ammonium nitrate. Sorry. It should be ammonium. So it is NH4NO3. Extremely sorry about that. Right. High temperatures. The total number of liters of gases formed at the standard temperature and pressure when 240 gram of ammonium nitrate is decomposed is. Now the problem is they have said water vapor is formed. No, people, water vapor is formed. Should we take it as a gas? That's my question now. Oxygen gas, nitrogen gas, oxygen gas, and water vapor. They have specifically told water vapor. So I'm wondering we should consider. Right, let's see. First, let me write the reaction. They have given you reaction. You should be able to write the reaction. Ammonium nitrate, NH4NO3. It's heated, and you get nitrogen gas, oxygen gas, and water vapor, H2O gas. High temperature, yeah. So solid here. They have 240 grams of ammonia. No, 240 grams of ammonia. And we have to check whether the reaction is balanced. I think the reaction is already balanced now, people, perfectly, isn't it? 2 nitrogen, 4 hydrogen. No, not balanced. Not balanced, sorry. You have 4 hydrogen here. So definitely we'll have to put a 2 in front of this. If I put a 2 in front of this, there are 4 nitrogen atoms, 2 here. Oxygen, there are 6. I have to put a 2 here. No, isn't it balanced already? 4 hydrogen. 6 oxygen. I have 2 in front of everything. No. I have to put 4 here. 4 because I have 8 hydrogen on the left side, so I have to put a 4 here. Sorry. Now balanced. No, now balanced. Now it is balanced. I have 8 hydrogen, so I put a 4 here. This is the reaction. Always remember, balanced reactions must be written. 240 grams of ammonium nitrate is heated, people. So yeah, let's first of all find out the number of moles of ammonium nitrate. To find out the number of moles of ammonium nitrate, what should be the first step? Finding the molar mass of ammonium nitrate. So molar mass of ammonium nitrate is going to be 14 plus 4 plus another 14 plus 48, 3 oxygen atoms. And what is the answer we are getting, people? Is it 80? Yeah, 80, exactly 80 gram per mole. That's a good sign because 240 is a multiple of 80. So number of moles of ammonium nitrate will be how much? That is mass over molar mass. Mass is 80 gram per mole and molar mass is 240. Mass is 240 grams and the other one is 80 gram per mole. And final answer is 3 moles. If you have 3 moles of ammonium nitrate, tell me how many moles of nitrogen will be formed? How many moles of nitrogen will be formed? 2:2, same number of moles, 3 moles, correct? How many moles of oxygen is going to be formed? 2:1, therefore it has to be half of it, that is 1.5 moles. 1.5 moles. Now my concern is water at standard temperature and pressure. When you say standard temperature and pressure, people, they are talking about what temperature and pressure? Standard temperature and pressure. So standard temperature and pressure are 0 degrees Celsius and 1 atm. 1 atm is roughly equal to 1 into 10 to the power 5 Pascal. Under this condition, water will be condensed to liquid. So I'm wondering whether we should consider it or not. What are they asking? The total number of liters of gas formed. That is the question. So these two itself, we have 4.5. When you multiply 4 by 4.5, what answer do you get? 100.8. If I take water also, if I take water, how many moles of water will be formed then? Tell you. How many moles of water will be formed? 3 moles means 2, here 4, so it's 1:2 is the ratio. If 3 moles of ammonium nitrate is reacting, 6 moles of water is going to be formed. 6 moles of water. So if I add water, it will be 10.5. 10.5 into 22.4 is probably 255.2. And if you ignore water, I think 108 will be the answer. Yeah, 100.8 will be the answer if you ignore this. So my question is the standard temperature and pressure. At standard temperature and pressure, how many? Right. So does anyone have the scheme for this one? Can I see raise your hands if you don't mind? Does anyone have the scheme? Right. Can you check the answer for this question? 2017-14 one. Let's see what they have given. My gut feeling says it should be the third one. Because at standard temperature and pressure, water becomes a liquid. That's the concern I have. So someone quickly check and let me know. Shahan, if not Shifa. Oh, 2, 3, 5 in the scheme, is it? 2 is given, 3 is given, 5 is also given. Shifa is saying 2. How can 2 be the answer? Nitrogen is there, oxygen is also there. 2 means 67.5. 67.5 can 67.2 means they have only considered nitrogen. How come? Total number of liters of gas formed at standard temperature and pressure. So they have accepted 2, 3 and 5 also. No? It's interesting. We'll have to check the original scheme. 2, 3, 5. Two, three, 5. Two 2017. This is 6th, not 14th. Lot of. Double check the question, please. Shifa, you also double check the question if you don't mind. Oh yeah, this is 2017 6th MCQ. This is 2017 6th MCQ. Sorry. This should be 2017 6th one. Not 14th one. 14th one is the one we did earlier. So they have made a small mistake in this tute. Right. And the original scheme says 20305. It says 20305 original scheme. Okay. So what I was trying to say is why I chose 3 words. Now I can't agree with 2, answer 2, because oxygen is also gas. Huh? That's what I'm wondering. Fine. So let's say it's like this: at standard temperature and pressure, water will turn to a liquid. At standard temperature and pressure, water turns into a liquid. Water turns into a liquid. So what is the total number of moles? Total number of moles of gases. That will be equal to the remaining gases, number of moles of nitrogen plus number of moles of oxygen. That is 3 plus 1.5 equal to 4.5 moles. And in chemical calculation, we have learned the relationship for moles. If you want to find volume, if you want to find the volume of a gas, it is number of moles into molar volume. Correct? So number of moles, we have 4.5 moles. Molar volume, we should know that is 22.4, but they have already given that 22.4 decimeter cube per mole. So when you multiply this, it will be definitely 100.8 decimeter cube or liters. 1 decimeter cube is 1 liter. Okay, that's why I went with third answer. They have accepted all the answers, but second I don't understand how they got second, because both nitrogen and oxygen both are formed. No? They have got the second answer only by considering nitrogen, but oxygen I don't know, right? So let's settle to this one, people. Fine. So I hope you guys understood this. And there's a similar question in 2015. So 17 to 14th one, this one, 6th one, and let's quickly go to molecular kinetic theory and see if we have any questions from 2017. Are there any from 2017? No. Compressibility factor, anything from 2017 or partial pressures? 2018 there is one in partial pressures. We have skipped that, missed that. Okay, no. I'll tell you what, we'll just continue under this topic. We'll do like last 10 years first, and then we'll move on to older ones. Right. So I'll continue. Right. Next question. It comes from 2015 and the 15th MCQ. A similar question, calculation part, is also involved most probably. Oxygen gas formed by thermal decomposition of KClO3 is collected by downward displacement of water. The volume of O2 collected, in such an experiment at 27 degrees Celsius and 1.13 into 10 to the power 5 Pascal pressure was 150 centimeter cube. Given that the saturated vapor pressure of water is 0.03 into 10 to the power 5 Pascal at 27 degrees Celsius, mass of O2 gas collected is interesting. Right. So we don't need to worry about the reaction happening with KClO3 when we heat it. If you really want to know, when you have KClO3 and if you heat it, what happens is you get KCl and oxygen. Put a 2 here, 2 here, then put a 3 here. Okay, right. So they have given the volume of oxygen collected. Some information they are provided to us, a piece of information. Volume of oxygen collected is given, that is 150 centimeter cube. 150 centimeter cube, but that must be taken as 150 into 10 to the power minus 3 meter cube. Temperature 27 degrees Celsius. Once again, we can't directly use it, we have to convert it to 300 Kelvin. Pressure, you have to be a little careful. Can you remember when you collect using downward displacement, you will be collecting gas like this now. You'll be collecting the oxygen gas like this, downward displacement method. Right. With oxygen gas, who else will be there, people? Can you remember? Here with oxygen gas, who else will be there? We have O2 gas. At the meantime, water vapor. So it will be a mixture of oxygen gas and water vapor. Therefore, total pressure is in fact equal to partial pressure of oxygen plus saturated vapor pressure of water vapor. I hope you can remember this from the morning lesson. So total pressure is the pressure they have measured, that is 1.13 into 10 to the power 5 Pascal, and partial pressure of oxygen we don't know, and saturated vapor pressure of water, it is 0.03 into 10 to the power 5. So partial pressure of oxygen is going to be 1.10 into 10 to the power 5 Pascal. That is the partial pressure of oxygen. So if you are going to apply the equation for oxygen, you have to know the pressure of oxygen gas alone. 0.10 into 10 to the power 5 Pascal. Right. Any other information they have given? No. They are asking for mass of O2 collected. So mass of O2 we need. and we all know molar mass of O2, it's 32 gram per mole, but when you substitute the value, you have to substitute it in kilogram per mole. So that is going to be 32 into 10 to the power minus 3 kilogram per mole. That is the molar mass of oxygen. Obviously, I'm going to use yes, correct. Sorry, Khadija, thank you for pointing it out. People, the volume is given in centimeter cube. Therefore, when you convert centimeter cube to meter cube, it must be multiplied by 10 to the power 6. Yeah, that's something I need to correct. 10 to the power 6. Right. Now let's apply the equation. PV equals nRT. And nRT can also be written as simple M over capital MRT. Remember, we have to find capital M, so I'll make that the subject, simple MRT over PV. But remember, you have to substitute everything in SI units. Oh wait, I didn't notice this. The answers are in grams. So if the answer is in grams, then therefore it's okay if you don't convert it to kilograms. You can leave it in grams, no problem. If the final answer you are supposed to find out should be in grams, then you can just leave it in grams. That's okay. That is fine, because final answer is not in SI units, no people. If the final answer is in SI unit, everything else should be in SI unit. So here no issues, I think. And I think we had to make the mass. We had to find out the mass of oxygen gas. It's not the molar mass of oxygen gas. So let's make mass of oxygen gas the subject. Mass of oxygen gas is equal to PVM over RT. Apologies. Mass, pressure you should put 1.01 into 10 to the power 5 into volume. I think we should substitute 150 Pascal into 150 into 10 to the power minus 6 per meter cube into molar mass. Molar mass we can put 32 gram per mole, because final answer is in grams, divided by RT. Now for R, what value are we going to choose? Temperature 27. So I think it would be easier if you used what value we will 25 by 3 for R. Do you agree with me? 25 by 3 joule per mole per Kelvin multiplied by temperature. Temperature is 300 Kelvin. If you put 8.314, the simplification will be complicated, I think. So let's see if we can simplify this and get the answer. Right, these 3 and this 3 will get this 300 will get cancelled out, and you get 100 here. 25 and 150 you can cancel them out and put a 6 on top. So at the bottom we have only 100, which is a very good news. And afterwards, if I multiply everything, what do I get? There's 100 at the bottom. M is going to be equal to, I have 1.1 here, 10 to the power minus 1 into 32, and divided by 100 as well. So 1.1 into 10 to the power 5 into 1.1 into 6 into 10 to the power 5 into 10 to the power minus 6 is 0.1, or 10 to the power minus 1 into 32 is 3.2. And don't forget, that is also divided again by 100. 6.6 into 3.2 over 100. When you multiply 6 by 6 into 3.2, what is the answer you're going to get, people? 32 into 66, sorry. I am getting a value like this, 21.12 over 100. So my answer is 0.2112 grams. That is the answer I'm getting, and that is very close to who? The first answer. I have made a small approximation here. Instead of 8.314, I have gone with 25 by 3, and we are getting an answer very close to this. Please someone check the answer for 2015 15th MCQ. See if they have got this answer. First one. So this, even if you don't know this equation, you can still do this question. Yeah, okay, first one. See, they have given the first answer. They have got the first answer. Okay. And if you put 8.314, your calculation will get really complicated. I have explained you. Use 8.314 if for volume or something else. If they have used 4.157, 16.628 or 8.314 itself, then only the simplifications will be easy. If not, you can take it as 25 by 3 MCQ. No? Then you will get a we will get an answer. It will not be the exact same answer. You will be choosing the answer which is closest to this answer. So in this case, the first one. Okay, done. And then moving on, next one. I think the next question is in Sinhala, but I'll just quickly explain it to you. संशुद्ध calcium carbonate नियदिया प्रतिक्रिया संपूर्ण वनतुरु रद्द करने लगी. A pure sample of calcium carbonate was heated until the mass was constant at 27 degrees Celsius and 1 into 10 to the power 5 Pascal pressure. The total volume collected was 4.157 decimeter cube. Ukto vayo paripurna yai upakalpana kalahot. If you assume that the gas release was ideal, what is the mass of the calcium carbonate sample? Okay, that is the question. So what are they doing? I'll just put that in words. A calcium carbonate sample, pure calcium carbonate sample. Pure calcium carbonate sample. Have they given? No, they have not given the mass. And they are heating it. They are heating it, and they are heating it at and volume of gas collected equal to 4.157 decimeter cube. Under what conditions? At 27 degrees Celsius and 1 into 10 to the power 5 Newton meter minus 2 or Pascal pressure. So the question is, what is the mass of calcium carbonate? That's all. All right. First and foremost, we have to write the reaction. This is a very common reaction when you heat calcium carbonate. Okay, when you heat calcium carbonate, you'll be getting calcium oxide and carbon dioxide. Calcium oxide and carbon dioxide. We know the mass of this. We don't know. Normally, what we do is we'll take it as number of moles. No? We'll take it as number of moles. So I'll take it as x moles. If you use x moles of calcium carbonate, how many moles of carbon dioxide is going to be released? X moles. X moles of carbon dioxide is going to be released. If I know the number of moles of carbon dioxide, I know the number of moles of calcium carbonate because both are x. And don't forget, calcium oxide is a solid. Okay, so our target is finding x and then finding the mass of calcium carbonate. It's a very simple process. You find the moles and then you multiply by the molar mass of calcium carbonate, which is 100. Then what should I do for carbon dioxide? Is the gas evolved? You apply PV equals nRT. Pressure 1 into 10 to the power 5 Pascal. Volume 4.157 into 10 to the power minus 3 meter cube. Okay, equal to number of moles of carbon, we don't know, x into R. For R this time you can put 8.314 into temperature 300 Kelvin. When you say 27 degrees Celsius, it's in fact 300 Kelvin. So this time I put 8.314 directly because of this 4.157 value, because when you simplify them, this is 2, this is 1, correct? Yeah. And then people, if you look closely on the left side, you will have 10 to the power 100. You will have 100 here, just 100. Is it? Yes, 100. And on the right side, you are going to have x into 600. correct? X into 600, 2 into 300, 2 into 300 is 600, and here, yes, 100. So you can simplify these two zeros, gone, gone. Therefore, I am getting X equals 1 over 6 moles. So number of moles of calcium carbonate, that is X, equal to 1 over 6 moles. Mass of calcium carbonate, that is number of moles into molar mass. Number of moles is 1 over 6. Molar mass is famous, it is 100 direct, exactly. It is 100 over 6. When you divide 100 over 6, you will be getting 16.66 grams, 67 grams. That is roughly taken as 16.7 grams. So I think the answer is the fourth one. Can someone quickly check this answer in the scheme? Let me know if it is correct. This is 2012. Old. I don't think you will have the old syllabus scheme with you. Sorry. So let's forget about that. Yeah. I think this should be the answer. And I hope you guys got the learning from this as to how to approach a question like this in future. Yeah, this is not very difficult. Write the reaction, put the number of moles carefully by considering stoichiometric ratio, then apply the ideal gas equation for the gas evolved, find its number of moles. If you know the number of moles of that, you know the number of moles of the solid reactant too. Okay, fine. This is 2012 old syllabus. Done. Right, next one. Next one is 2006. Right, interesting. A 30 milligram of sample of volatile liquid is vaporized at 127 degrees Celsius. The volume of the vapor phase measured at 1 into 10 to the power 5 Pascal is 16.65 centimeter cube. 16.65. Okay, interesting. It is not 8.3, but roughly. Okay. If the vapor phase behaves ideally, the liquid is most likely to be. So they have given you how many liquids? 5 different liquids. So we have to choose which one of them has the highest possibility. So if they have given if we are supposed to find out which gas it is, we have to find out what. To decide the type of the gas, we have to find out the molar mass of the gas. This carbon dioxide has 44, oxygen has 32, nitrogen has 28. Likewise, if you find out its molar mass, you can make a prediction about the gas. Right. So what are the numbers given? A 30 milligram sample of a volatile liquid is vaporized at 127 degrees. So mass is given as 30 milligram. Mass is given as 30 milligram. If the mass is 30 milligram, in grams it is going to be 30 into 10 to the power minus 3 grams. Okay. Why am I doing it in grams? Because I don't mind if my molar mass comes in gram per mole, because we normally use that. Temperature 127 degrees Celsius, but unfortunately we can't use that directly. It has to be how much? It has to be 400 Kelvin. You add 273 to that. Pressure is also given 1 into 10 to the power 5 Pascal. What are they asking us? Okay, we have to find the molar mass, people. If you find the molar mass, you have your answer. So yeah, let's start. PV equal to nRT. Instead of n, you can put simple m over capital M RT. So if I make capital M the subject, it's going to be simple M RT over PV. So capital M is equal to simple M. Simple M is mass, that is 30 into 10 to the power minus 3 grams. R as usual 8.314 joule per mole per Kelvin. I will let's see if we can do something about it. Temperature 400 Kelvin. Done. Now at the bottom in the denominator, right, in the denominator, people, it's PV. Pressure is 1 into 10 to the power 5, isn't it? 1 into 10 to the power 5 into temperature is 400. 1 into 10 to the power 5 Pascal, or Newton meter minus 2 into 400 Kelvin. Right, these are the numbers. Now I'm going to do no PV temperature is not down. No, volume is volume I have forgotten. Volume is 16.63 centimeter cube. 60.65 centimeter cube. No, that is 16.65 into 10 to the power minus 6 meter cube. You can change only mass to grams because I need the final answer in gram per mole, but the rest should be in SI units. So it's 16.65 into 10 to the power minus 6 meter cube. Since we can, if you take methanol, now you don't know what these things are, I will explain them, don't worry. Now, since this is an approximation they are expecting us to do, 8.314 and 16.65, I can simplify and put 1 and 2. Because 8.314, the double of that is 16.628, which is very close to this number. 16.628 and 16.65 are very close numbers. So roughly I'll take this as 2 and this as 1. Okay, what else? At the bottom I have 10 to the power 5 and 10 to the power minus 6. That is going to be 10 to the power minus 1 at the bottom. And top also there will be what? There will be 3 zeros, you see, 3 zeros. So 1, this 0, and then these 2 zeros can be cancelled out with this 10 to the power minus 3. 10 to the power minus 3 into 1000 is 1. So not bad. And then this 2 and 4 you can simplify now after that. This 2 and 4, if you simplify, you will be getting a 2 here. So I have on top I have 3 and 2, that's all. Capital M is equal to 2 and 3 involved, it is 6. What is this number? 1 into, no? This is 1 into, I have written something here. Oh sorry, I think I have missed 2. Yeah, the 10 to the power 5 and 10 to the power minus 6 you can simplify now, people. Simplify them and put 10 to the power minus 1, right? Okay, so on top 6 at the bottom 10 to the power minus 1, so the final answer is 60 for me, approximately. Anyone who got 60? Try this question and got 60 gram per mole or molar mass. Right, so I see a few hands going on, but unfortunately you don't know what these compounds are, so let me write down their chemical formulae. Methanol is CH3OH. Ethanol is CH3CH2OH. Acetone is CH3COCH3. This is acetone. Chloroform, CHCl3. Carbon tetrachloride, tetra means 4, so CCl4. Which one do you think matches this molar mass the most? Right, for the first one, if you take the molar mass, four plus oxygen 16, 20, 32. First one is 32. This one, there are 2 carbon atoms, 24, 1 oxygen atom 16, 24 plus 16 is 40, and then I have 6 hydrogen atoms. No, oh no, there's another hydrogen, 6 hydrogen atom. So 24, 46, I'm getting 46 people. And here 3 hydrogen atoms, and also there's an oxygen atom. So 3 carbon atoms, an oxygen atom, and 3 hydrogen atoms, and that is, I think, exactly molar mass is 60, isn't it? 36 plus 6 is 58. I'm getting 58, I think. 58 is it? 6, 42, 58. Yes, 58. And CHCl3 is much higher now, people. CH3L3 is going to be much higher because carbon and hydrogen 12. 3 chlorine means 35.5 into 3, that is 106.5. 106.5 plus 13 is 119.5. That's way too high. And CCl4, it is also a big number. Carbon is 12, Cl4 is 35.2 to the power 2 into 4, that is 142, na? 142. No, 142 and 154. 154. This is going to be 154. That is also varying a lot. 4 chlorine will be, people, 4 chlorine will be 142. 1 carbon added to that, 154. Done. So which one do you think is the best option? We have got 60 as the answer. Out of all of them, who is the closest to 60? Acetone. Okay. Right. Fine. So that's the answer, 2006.